Professor Bazzi, before you hit record, oh, sorry.
In exercise 15 to 18, the scatter plots show the results of a survey of 20 randomly selected males, ages 24 to 35. So the males are 24 to 35 years old, 20 of them. So you should see 20 points there if you count them in each graph. Using age as the independent variable. And by the way, guys, the independent variable is called the explanatory variable. And Y is called the dependent variable or called the response variable. So explanatory means independent and response means dependent. So using ages as the explanatory variable, match each graph with the appropriate description. Explain your reasoning. So age and body temperature, which graph would that be? Remember, the age is increasing, going from 24 to 35, can be anywhere. So which graph, guys, do you think will resemble body temperature? Assuming that we are all healthy and not sick. All those 24 to 35 males are normal people without any illness issues. Which graph would represent age and temperature?
18.
Do you guys agree it is 18? Because whether I'm a math teacher or I'm a physics teacher or you're a doctor or you're a student, normal temperature has to be about 98. And look, guys, very much the same temperature here. It is correct, that's 18, I agree. Yes. So A is D. 18. Not D, I mean Asian body, it's number 18. Okay. Age and balance on student loans. You take a loan, guys, when you first go to school, and then eventually you have to pay it off. You don't have a choice but to pay it off at a certain time. Which one do you think would reflect on this situation? I say I agree with 17. Look, as time passes, guys, and you get a job, you're going to be making payment, and eventually they don't give you more than 10 years. So in 10-year time, eventually your balance has to go to zero. I agree. This reflects, just an age imbalance on student loan. So that's number 17. Age and income. You get a job. Usually the starting salary is not great, guys, but the more you build seniority and more money you're going to be making. So what do you think? Which one is going to be? 15. Very good, Mandy. Okay, I agree. More time on the job, more money. That's how it is at most places, guys. Not for teachers, guys, for your information. They put us on a freeze, for so many times. So age and height. Well, I know you're going to tell me that there is only one left for this, but sometimes I'll give you 5 graphs and I ask you to pick 4 situations. Did you notice, guys, that the height will tend to go a little bit lower, just with age, because as people age, they start having some back issues, and that could affect the height by a little bit, not much, but it's pretty much stable, as you can see. So 16 will be age and height. I hope that this exercise will give you a feel, just on how you can interpret those scatter plots. Now, if you ask me to find the value of R, probably I could tell you R is very close to 1 here, 0.9 something. I don't know. I have to put the values into a calculator. Here, this is going to be negative, but it's not as big as that one. So probably negative 0.99192. Here it might be perfect, almost perfect, guys. So that's going to be in the 9, very close, just to 0.99 something. Here, kind also, just it will be strong. So there is correlation, just in all of those cases. The good news is we can use the calculator to find R. All right. So again, guys, X is called the explanatory variable or the independent variable, and Y is called the response variable or the dependent variable right here. Okay. You learned how to find the line and how to sketch the line using your calculator. We did that. And that's what I sketched. This is called the slope of the line, and this is called the y-intercept of the line. As we said, as the values of x increases and if the value of y decreases, we say x and y have negative correlation. In order to determine the strength of the relationship between the variable x and y, we find the sample correlation coefficient R, which you learned how to find it. So that's R. And guys, I explained to you how to interpret the value of R. This is how you find R if you didn't set it up on your calculator today. Okay. What we're gonna do, we're gonna do a part of this exercise now. Example 1, this example covers all of the objectives of chapter 9 that you need to know. Let X be the age of a child in years and let Y be the number of irrelevant responses on a standard test appropriate for the child's age. If you give a test to a child who's age 2, they're not going to be thinking of the answer. They'll be thinking of the answers and making sense of them. They're just going to choose whatever. So the number of irrelevant responses is going to be very high. But when the child gets older and older and more mature, you're going to see that the number of irrelevant responses tend to go down because they start thinking, they start putting their knowledge in there rather than just picking up any answer and telling you that this is the answer. So what I like you to do, guys, the first step is to put the data, the X value, which is the age of a child, in L1, and the number of irrelevant responses in L2. So that goes to L1, and that goes L2. Always in this chapter, the first thing that you have to do, guys, without even thinking of anything else, put your data in L1 and L2. That's step number 1. Before I do anything else, here's a question for you. What do you think? Is it going to be positive or negative? Without any calculation. Is R going
Positive?
to be positive? As X increases, Y increases. What do you notice as X increases here? What happens to
Negative.
Y? Negative, exactly. So you should be sure, guys, 100% sure that the R is going to be negative, because you notice as I increase the value of X, the Y values tend to decrease. So we know R is going to be negative, but the calculator will do that for us. Okay. Here's the first question. Create a scatter plot of the data set. So how did we do the scatter plot? If you remember, you already did the settings here, guys. You're done. You don't have to do it again. So I'm just going to quit. I'm going to hit zoom and then number 9. But before I do that, let me clear the Y, because this graph I don't need here. So clear. And now I'm going to go to zoom and then number 9. There you go. All right. That's the scatter plot. The next question is to find the value of R. Okay. How do I find the value of R? So that answers the first question already there. I got the answer. This is a worked out example, guys. I worked out the answer. I created, this graph using static crunch, but you can see it's exactly the same thing on your calculator. Watch, guys. Perfect match between the two. The second question is find the correlation coefficient R and comment on the relationship in words between X and Y. X is the age of the child, and Y is the number of irrelevant responses. Okay. Whatever I did earlier, guys, I do stat, calc, number 4, enter, and just calculate. Here is R. If I ask it to round R to two decimal places, will be negative 0.97. And actually, I did the math there, so let me show you. Using the calculator by following the steps above, R is negative 0.97. Since R is very close to -1, then you're right. There is strong, negative, you can say very strong, negative, linear relationship between X and Y. And I prefer, instead of X, to put age of the child and Y, which is the number of irrelevant response, not relevant responses on the test. On the standard test. Okay. Any questions so far, guys? So we did part A and part B. Part A to sketch the graph. Part B is to find the value of R. Part C, you already done it on the calculator. Find the equation of the line of best fit, the regression line. Use your calculator and the steps explained above to derive the equation. Well, we already have the equation, guys. It's right here. Let me just show you. Okay. So if I write y equals ax plus b, and I plug in a by its value, guys, let's do to 2 decimal places, will be negative 0.96x plus b. You can see b, guys, it's 17.296, rounded to 2 decimal places will be 17.30. And this is called the equation of the regression line of best fit. Now you notice that I put a hat right there on top of y. We put a hat to say that this equation was generated from a sample of data. It's a data that comes from a sample, so just put y hat. So y hat equals negative 0.96x plus 17.3. And that is the equation, guys. It's right there. This is exactly the same as that. The only difference is, guys, that I put the negative 0.96 later instead of putting it, first, but it's exactly the same thing. Now, if you want to show this line, guys, on your scatter plot, you want to show it, here's how you show it. Watch. You just go to y equals, and you want to see this line in action. Okay, since I'm putting a negative sign first, you have to use a negative sign right here. So that's a negative. You cannot put a minus here. 0.96 x, there's the x right there, plus 17.3. Okay, graph. The calculator does a lot of efforts to find the value of b and find this line of best fit. Otherwise, it's a very challenging task to find the line of best fit by hand, but this is all done using technology. You can see some of the points are not on the line, some of the points are on the line, because that's the best we can do to get the line of best fit, and this is called the line.
Mine doesn't draw the line because I use the old calculator.
No, it should work. I can troubleshoot that, just
Okay.
before the end, just of this lesson, because I will stop, just a few minutes before we end. Yeah, it should do it. Just make sure that this one is not turned off, just the equal sign. Sometimes, so just make sure it looks exactly like mine, and it should work. Unless if you didn't put the minus sign correctly. So it should be the minus, the negative sign from here.
Well, when I go and I push the Y, it enters the information in for me automatically.
Oh, it did? The same
Yeah.
information that I have?
What I put in the same information and oh no, it didn't. My apologies. Nope.
Okay. Right. Now, so we did A, we did B, we did C. I'm going to leave D till Wednesday, and I'm going to do part E now. You can see a lot of explanation, guys, because I'm trying to explain everything in the handout, but watch here. Find the predicted number of irrelevant answers on a standard test Y when the age of the child is 8 years. Okay, let's see how, guys, you would answer this question. You have the equation that relates the age to the number of irrelevant responses. It's right there. I'm asking you to find the number of irrelevant responses when the age of the child is 8. What would you do, guys, to do this if you have the equation? Any ideas?
You put 8, you sub that for X.
Exactly. So when I give you the X value, guys, and I'm asking you to find the Y values, all you need to plug in the X equals 8. And that's what I did, just on this page. So let me just go to that page again. When X is 8, just plug in X equals 8 in there. So it would be negative 0.9. I use negative 2 digits, but here in the handout, I use 3. That's fine. Negative 0.96 times 8 plus 17.3. So if you just want to show you on the calculator how you get the answer, it's very easy to do it. So let's just clear everything. And you just put negative 0.96 times 8 plus 17.30. And there you go. The number of irrelevant responses is 9.62. But because the response cannot be a decimal, so it has to be a whole number, I would say it's about 10 irrelevant responses. It's just rounded to 10. Okay. So we are next page. We're here. Right here, part E. Okay. Here's another question now. Let's go back to the data set, and we have the equation. This is the equation, guys. Remember that. And what would be the number of irrelevant responses if the age of the child was 6 years? What would you do? You already
Instead of multiplying it by 8, you multiply that by 6.
Exactly. You just plug in 6, so it will be negative 0.96 times 6 plus 17.3. About 12 irrelevant responses. You see, the younger the child, the more irrelevant responses you have. What would be, now pay attention to this, and I like you to look at the data set. What would be the number of irrelevant responses if the age of the child was 15? So if the child was 15 years old, what would be the number of irrelevant responses? So you guys are going to tell me plug in X equals what? 15, correct? Just like we did with 6 and 8. But that won't work. I like you to probably try to figure out what I'm trying to say here. If I give you X equals 15, you tell me that can't be done. Why? We cannot use the equation of the line of best fit to figure out the number of irrelevant responses when the age of the child is 15. The equation will break here. Wouldn't be a good equation. What's the reason? I'd like you to look at this. Any guess why do you think 15 wouldn't cut it on the equation? What's the lowest age that we have, guys? 2. What's the highest?
12.
The model is only good for any ages between 2 and 12, including 2 and 12. The model will break down, just when you go beyond, those two numbers in there. So you will not be able to use the model to find the number of the y values when x equals 15, because 15 is outside of the range. So what would be, let's say I insist, I need an answer from you about what would be the y value when x is 15. Here's what statisticians decided to do in this case. If this x value falls outside of the range and you cannot plug it into the equation, here's what you can do, guys. You will do the average of all the y's and you make it your answer. So how do I do the average of all the y's? How many y's do I have? Just add them up. Watch. 15 plus 15 plus 12 plus 13 plus 11 plus 10 plus 8 plus 6 plus 5. I got 95. And how many children do we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9. So you just take 95, guys, and divide it by 9. And that would be your answer. Is this the correct answer? No, but that's an estimate. You just do the averages of all the y values. So if your x value fall outside of the range of 2 to 15, to 12, whatever it was, you cannot just plug in the value into the equation. You have to use the average of all the y values in this case. Okay, so that's what I put in writing here, guys. I just try to explain, just to you what we do right there. Any questions? So what we learned so far, guys, is how to put the x and y values in L1 and L2, how to graph a scatter plot, just of the data set, how to find the value of R and make a comment on R, whether you have a strong positive linear correlation or strong negative linear correlation based on the value of R, whether it's very close to 1 or -1. And you learn, guys, how to find the equation of the regression line, which is the y equals ax plus b. We call it y hat. And you learned if you are given an x value, how to find the y value by just plugging in the x value. The last thing I wanted to do, guys, and then we will be done for today, is if you are given the y value, how would you find the x value? Let's say the equation of the line, guys, here was y equals, what was it? I'm just going to get it from negative 0.96 x plus 17.3. Okay, it was 17.3. Let me just make sure. Yes. What about if I give you the number of irrelevant responses and I want the age of the child?
Then you plug that number for y and then rearrange
Number of
it.
irrelevant responses, let's say 8. What was the age? This is a little bit of algebra, guys. That's the last thing I'm going to do today. What was the age of that child? So, as you said, if I give you the number of irrelevant responses, 8, you don't plug it in x because x is the age of a child. You plug it here. So you do 8 equals negative 0.96x plus 17.3. And let me show you how to solve this algebraic equation. You need to find x, guys. In order to find x, you need to isolate, just the x. So you have a plus 17.3, you do a minus from both sides. Eight minus 17.3, guys, will be negative 9.3. Equals negative 0.96x. Now, in order to find the x values, all you need to divide by the number that's attached to x. So just divide both sides by negative 0.96, negative 0.96, and then your x will be, let's do it on the calculator. Negative divided by negative is positive. So I'm just simply going to divide 9.3 by 0.96. Clear? 9.3 divided by 0.96. So the age of a child is about 10 years, 90.68 years, 9.7 years. If he says, give me a whole number, just say about 10 years old. So that's it.